There are numerous substances in the world. All of them are made up of smaller basic substances. By applying chemical methods, we can break substances down into smaller units of substances. The smallest unit, which cannot be broken down further, is called an element. When two or more elements join together through chemical means, the substance formed is called a compound. Elements constituting the substances on Earth have different quantities. Up to now, scientists have discovered more than 110 elements. Let's take a look at some examples of elements and see if we know how to classify them. There are so many elements. Obviously, we can classify them according to their state. Some are solid, some are liquid, and some are gas. Apart from this, there is another common classification, which is to classify them into metal and non-metal respectively. Up to now, among all metal elements discovered, the only one in liquid state is mercury, while all the remaining ones are solid. Metal elements are usually glossy on the surface. They can either be crushed into thin slate or stretched into thread form. When heated, metal will soften, change shape, and even melt at high temperature. There is also another special characteristic of metal elements. They can all conduct electricity. This instrument can detect if a substance can conduct electricity. By connecting the two testing sticks, the instrument beeps. We can use it to test some of the metals. As the instrument beeps in each of the tests, it shows that metal can conduct electricity. How about non-metal elements? This is sulfur, a kind of non-metal element. Natural sulfur exists in hot springs around volcano regions. This is charcoal, made up of carbon, which is also a kind of non-metal element. Unlike metal elements, non-metals are matte on the surface and are usually crispy and easily broken. That is why, normally, no one would use non-metal elements to make jewelry or daily utensils. Almost all non-metal elements cannot conduct electricity. The only exception is graphite. The electrode inside most dry batteries is made from graphite. Like charcoal, graphite is made of carbon elements, but with different arrangements of the element particles. In fact, the colourful, dazzling diamond is also composed of carbon element, but the particles' arrangement is different from either charcoal or graphite. Now, let's take a look at classification according to state. Some non-metal elements are in solid state, including carbon, iodine, and sulfur. There is only one type of liquid non-metal element, bromine. However, there are plenty of gaseous non-metal elements, including oxygen, nitrogen, chlorine, argon, and hydrogen. Scientists use different combinations of letters to symbolize different elements. For example, the symbol for calcium is Ca. Sodium is symbolized by Na. On the surface, Na seems to have little connection to the word sodium, but in fact, Na comes from the Latin name, natrium. Elements are made up of atoms. At the center of all atoms is a nucleus. A nucleus is usually composed of two types of smaller particles. One is positively charged particle called protons. The other is non-charged particle called neutrons. Protons and neutrons are similar in size and weight. On the outer layer of an atom are some very small negatively charged particles called electrons. As the number of protons and electrons inside every atom is equal, the positive charge matches the negative charge. This allows the entire atom to maintain its neutrality without any charge. As the electron is much lighter than either the proton or neutron, the substance of an atom is concentrated almost entirely at the nucleus. We can use a metaphor to illustrate the structure of an atom. If an atom is like a football field, then the nucleus is like a pea in the center, and the electrons make up all the remaining part. The atoms of different elements are constructed differently. For example, in the hydrogen atom, there is just one electron, while the nucleus contains one proton and no neutrons. In the carbon atom, the nucleus contains 6 protons and 6 neutrons, and there are 6 electrons on the outside. In the iron atom, there are 26 protons and 30 neutrons in the nucleus, and 26 electrons on the outside. The number of protons inside an atom can be used to ascertain what kind of atom it is. When there is only one proton inside the atom, it must be a hydrogen atom. When there are 2, it must then be helium, and so on and so forth. If it has 6 protons, it is a carbon atom. With 7, it is nitrogen. With 8, it is oxygen. And with 17, it is chlorine. Different elements are composed of different atoms. However, the arrangements of the atoms may not be the same. In hydrogen, for example, 2 atoms form a group, and the distance between groups remains relatively large. This explains why hydrogen is in a gas state. Oxygen, nitrogen, and chlorine are all formed by groups of 2 atoms, and they are all gas. Metal elements like sodium, calcium, and magnesium are usually formed by lots of atoms packed together into fixed positions and arranged into giant structures. As the atoms are arranged in a dense matter, the elements are in a solid state. Apart from individual elements, many substances in the world are composed of two or more elements, joined together through chemical means. These are called compounds. Different compounds are composed of different elements. For example, sodium chloride is made up of sodium and chlorine. Water is made up of hydrogen and oxygen. Copper sulfate is made up of copper, sulfur and oxygen. Alcohol is made up of carbon, hydrogen and oxygen. They are all compounds. Sodium is a glossy metal that's silver in colour. It is a kind of element. Although it is metal, it is not as hard as iron and can be cut with a knife. Sodium reacts vigorously with water. It moves along the water's surface, releasing white smoke. As a large amount of heat is discharged, the sodium melts into a sphere and finally disappears. As there is water on the surface of our skin, we cannot touch sodium with our bare hands. Even air also contains water vapor. Therefore, we have to store sodium under paraffin oil to minimize danger. Chlorine is a yellowish-green gas with a pungent smell. It is toxic. It is a kind of element. As chlorine has disinfectant properties, it is added to our drinking water during the water treatment process to ensure that the water is bacteria-free when it reaches our homes. Chlorine is also added to the water of public swimming pools to keep them hygienic. If we place a colourful flower into a flask containing chlorine, the colours of the flower fade rapidly, which indicates that chlorine has a bleaching effect. The pungent smell of bleach is caused by the fact that its main component is chlorine. When a piece of sodium is placed into chlorine, a large amount of white smoke is emitted. This is actually composed of very fine white solids, which are neither sodium nor chlorine, but the compound formed by them. They are sodium chloride. Sodium chloride is the edible salt that we commonly use for seasoning. The nature of it is very different from that of either of its component elements. It is an entirely new substance, formed when sodium and chlorine combine and undergo chemical change. Both sodium and chlorine are dangerous. Sodium can scorch skin, while chlorine is toxic. However, sodium chloride is not only non-toxic, but even edible. It is also indispensable in keeping our bodies healthy. Inside the sodium element, sodium atoms are tightly packed together, so it is a solid. On the other hand, each chlorine molecule is made up of 2 chlorine atoms. Under normal temperature and pressure, the chlorine molecules are far apart from one another, so chlorine is a gas. When there is a chemical reaction between sodium and chlorine, they combine to become sodium chloride. Its structure is different from that of both sodium and chlorine, therefore it has different properties. This is the metal element magnesium. The gas inside the gas jar is element oxygen. Heat a small piece of magnesium over a flame until it ignites. Then immediately place it inside the gas jar containing oxygen. A dazzling white light and a burning flame appear. After a while, the flame dies out. Now, check the flask to see that lots of white powder has formed. This is the compound formed by combining magnesium with oxygen, namely magnesium oxide. Magnesium is a metal that conducts electricity, while oxygen is a colourless gas. However, their compound, magnesium oxide, is neither a gas nor an electric conductor. It is a white powder with entirely different properties from its component elements. It is a new product. Iron and sulfur are two different elements with very different properties. Iron is drawn to magnet, while sulfur is not. If we mix iron powder with sulfur powder, we can still use a magnet to separate them. However, we may place the mixture into a test tube and heat it for a period of time. Wait for the tube to cool. The mixture now has become a black solid, and the yellow of the sulfur has disappeared. When tested with a magnet, nothing happened. Obviously, the properties of the black solid are very different from that of its component iron and sulfur. It is a brand new product called iron sulfide, a compound formed by combining iron and sulfur. Sodium is a dangerous metal and chlorine is a toxic gas. But the compound formed by them, sodium chloride, is not only non-toxic but essential for the human body. The process of combining sodium and chlorine to obtain an entirely new substance, sodium chloride, is called chemical change. During the chemical change, sodium and chlorine are the reactants, while sodium chloride is the product. For all chemical changes, the product is different from the reactants in that it has an entirely different property. This is the characteristic of a chemical change. Magnesium combines with oxygen to form magnesium oxide. As the properties of magnesium oxide are entirely different from those of the component magnesium and oxygen, this process is also a chemical change. Magnesium and oxygen are the reactants. Magnesium oxide is the product. Likewise, iron and sulfur combine to form the compound iron sulfide. Iron and sulfur are the reactants, while iron sulfide is the product. In chemical change, there is always an obvious change in energy. Also, chemical change is normally hard to reverse. For instance, it is not easy to convert sodium chloride back into sodium and chlorine, or to convert magnesium oxide back into magnesium and oxygen. When water is heated, it turns from liquid into steam. Is this process a chemical change? Here both the liquid and the steam are water. The only difference is the distance between the water particles. In liquid water, the distance between the water particles is shorter, whereas in steam, the distance between the water particles is greater. But both are still water. No new substance is formed. Therefore, the process of liquid water turning into steam is not a chemical change, but a physical change. Let's take another example. A glass falls to the ground and breaks into pieces. Despite the change in appearance and shape, all the broken pieces are still glass. They still maintain the characteristics of glass. Therefore, the process of breaking a glass is a physical change, not a chemical one.